Hi everyone, today we are going to talk about statistics and data. So what is statistics? There could be many different definitions, but I'm going to give you some definitions that I really like. The first one is from Tor Rager. He is my PhD advisor. He looks like this, and he's a professor in psychology and neuroscience department at University of Colorado Boulder, but he's moving to Dartmouth University this year. And he said that statistics is about asking questions. It is super important to asking the right questions and using data to answer those questions. Okay? So first, we need the questions. We have to know what the question is, and we want to use the data to understand, to get the right answers. The second quote is from Martin Lindquist. He's another important person to me. He's a professor at Johns Hopkins. He looks like this, and at biostatistics. I worked with him on many different projects, and he actually teaches a lot of statistics courses. And he said statistics is the science of collecting and analyzing and interpreting data or factual information. The factual information is in other words, it's data. Okay, so in the current day era, now you might heard a lot about big data. It's data era, big data era, right? So we really need to know how to collect and analyze and interpret data in the right way, right? Yeah, he's a Tor's good friend and colleague and something like co-advisor for me. And from the textbook that I'm gonna use throughout the course, the textbook says statistics is a way of reasoning. Okay, wait. Reasoning along with the collection of tools and methods designed to help us understand the world. Yeah, we want to understand the world, but before that, we need, the data is kind of way to understand the world, to see the world, right? And we need a lot of tools and methods to actually see the patterns in the data. Okay, so statistics is becoming more and more important. Why? So these are the examples that I really love. These are from a paper the paper I love, Freeman et al. Nature Method. He talked about, this paper is about how to analyze big data in neuroscience. Okay, and the left side, the figure is an image from light stream microscopy. It seems it's not animating right now, but you can see the animation here. See this, it shows the single cell level activation of larval zebrafish's brain. It really produces a lot of data, 1 terabyte data per hour. Okay, so now you have the tool to see single cell level neuronal activity, but it provides a lot of data. And if we don't know how to process this data, we cannot see the world using this data. And on the right side, you are seeing an fMRI data from that. This figure is from Alex Us's 2016 paper, Nature paper, while participants are listening to a story, how the brain looks like. Okay, let me animate this again. This fMRI is the tool that I'm usually using for my study, fMRI. And in our lab, we are scanning whole brain within last a second, 1 second, like 460 millisecond, with really high resolution, spatial resolution. Okay, so it produces a lot of data, rich data, and per hour, yeah, it requires a lot of storage. So in the lab, we are purchasing storage. Okay, Okay, so this, as I said, this paper is by the Freeman, and this is the book by Jeremy Freeman. Who is Jeremy Freeman? I think I like him. Jeremy Freeman, he previously was Genelia Farm Research Campus. This is an amazing research campus, similar to our N Center, CNIR. We have a great center here, right? In this N Center. This is IBS Center. Actually, we aim to build something like Genelia. Genelia has like a really open science culture, and they have great campus. Anyway, so they had this guy before, but he's now at Chan Zuckerberg Science Initiative. So Facebook took him, okay. But before he moved there, he published published a book with Gary Marcus. He's another guy I really like. Anyway, in his book, in his chapter, he say these are quotes from him that new technologies are now finally allowing us to probe the activity of thousands of neurons simultaneously. Okay, so in vivo, the living brain activity, we can get those activities simultaneously while animal perform rich ethologically relevant behaviors. It's amazing, right? And the challenge here is, the first challenge to converting this newfound torrent of neural measurement into fundamental scientific meaning is to ask how to make sense of the data. Oh my god, this is the phrase I love. This is, in other words, statistics, I think. Okay, so this is my definition. Statistics is a scientific way of searching for meaning. Okay, wait. I'm not good at this, using pen with this PPT, but I'm learning. So my definition for statistics is a scientific way of searching for meaning out of data. Okay, enormous data, large amount of data. Just by looking at the data, you cannot see or you cannot find patterns. But with statistics or data science tools, you can see and you can find meaning out of the data. But the problem is that people see only what they want to see. Okay, and statistics can serve as a lens to filter data. So the problem is they can use statistics to lie. Okay, so from Martin's stat class, in his slides, he say, there's 3 types of lies. One is lie, damn lie, and statistics. Okay, statistics can be used as a lie. Okay, and always approach statistics with a critical eye. This is super important. Okay, we need to know what to use in the correct way. What is the correct way to use statistics? And from Thor's class, he said you can say anything with statistics. That's not a good thing. So statistics don't lie, but people can lie with statistics. So the bad thing here is people, not statistics. So I like statistics, but maybe I don't like bad people who use statistics for their own purpose. Okay, so here, this is really important. Manifestos. A statistician's manifesto is originally from Hasty. He's a really famous statistician. Okay, and I got this from Jordan Boyd Graber's class on machine learning, and I really liked this. I posted this on Facebook one time, so I want to share this with you. So the first manifesto is understand the ideas behind the statistical methods. You have to know what's the idea behind the method. Okay, so you know how to use them, when to use them, and when not to use them. Okay, so these are important. Okay, and complicated methods build on simple methods. For example, deep learning. There is a really complicated method. Okay, it's basically statistics method. with many optimization and multiple layers. But that really builds upon the simple methods, just backpropagation that is similar to simple regression. Okay, so simple methods first. So the results of the method are of little use without an assessment of how well or poorly it is doing. So we need to evaluate how well a method is doing or how well a model is doing. So we always need to think about how to evaluate the model or method. So these three are super duper important. Okay, so I'm going to give you an example of data. Okay, this is an example. Can you really figure out what this is? You might not, right? What is the problem here? There's no context. We cannot make sense out of this table. But if you have, so this is just reorganizing a table, but you can now understand this table, right? So there is a purchase order and name, who ordered it, and ship to states. Yeah, like the name and states. This is maybe the address of the person who ordered this product, and price and the area code, any yada yada yada. Okay. So this is maybe the purchase list from maybe Amazon or something. So here the point is, it is super important to understand the context of your data set. Usually 5W and 1H. Who, what, when, where, why, and how. So when you see the data, you have to ask this question, 5W and 1H. If someone give you the data and say, oh, figure this out, and then you have to ask, oh, please give me 5W1H. Okay. Okay, so this is repetition, and we want to know who was measured. So the who the data were from, and what was measured, and how and where the data were collected, and when and why the study was performed. Okay, I'm gonna circle all these important things. Always keep the track of the unit of the measurement. This is important, another important thing, because a unit can be changed, and if without unit, the value we don't know, we cannot know the meaning of the data, what the value means. Okay. Okay. So data table. So there is a common way to provide the data with the data table. So variables are the characteristics observed, recorded about each observation, and here these are variables. Usually we put these variables in columns. So different columns have different variables, and this way is observations. Okay, each one is observation. This is not new one. Okay. Oh, actually, this first. Let's make a data table using the data I collected last year. Actually, I didn't collect this data this year because there were too many people in the class. But last year, we had only 14 people, students. And then I asked them, how many hours did you sleep last night? And how do you sleep on average? How many hours do you sleep on average? And I got the data. And here I can say these are variables, and these are observations. Okay, and this is not new. It's an old tradition. Actually, from this this book, I mean, I really recommend reading this, The 7 Pillars of Statistical Wisdom. And there was an example of old data. So this is I don't know what this is, but maybe the recording the time based on the sun and shade. Anyway, the important thing is here. The variable is here. It's already how many years ago? Like 500, almost 500 years ago. The same data table these were observations. So this type of data table is an old tradition. Okay, so next topic is there are many different types of variables. The first one is categorical variables. So a categorical variable is like gender, hair color, car model. So we cannot make it as a like continuous values. Those are like the groups and categories. So we call it categorical variable. So easy, right? And there is a quantitative variable. This is continuous variable like height, age, miles per gallon for a car. This contains numerical values that are measured in units. Each value has a meaning, right? Larger value usually means large things. Height, like taller guy has the higher number for the height, like that. And there is other types like identifiers and ordinal variables. And identifier is something like student ID or customer number, just unique number, right? Unique number generated by the machine or something like the 주민번호, okay? What do you call it? The 주민번호? I don't know. In America they say social security number is similar to 주민등록번호. So we are getting those are identifier variable. So personally identifiable information. Like for example, if I get the many different values, like when you slept, went to bed yesterday night, and your height and your weights. Without this identifiable information, I cannot link the data with someone, right? But if I have your 주민번호, and then right away I know what the value is for. I mean, who the data are for. Okay. This is kind of really important because for the security nowadays, sharing when you want to share the data, you can only share data, the identified data. Okay. Because we don't want to kind of use someone to use those data for bad things. They can do bad things about you if they know who this is collected from. The second one here is ordinal variable that report order without natural unit, and usually it's used in survey. For example, let's say I ask you this question: how valuable do you think this course will be to you? And some people say, oh, I don't like this class so far, and I'm gonna give you 1. And some people, oh, I like this, and 5. For example, if I use this scale, like 1 for worthless, and 2 is slightly, and 3 is middling, and 4 reasonably, and 5 invaluable. And so ordinal variable uses this like ordinal variable. Okay. Lastly, I'm going to talk about distribution. Each variable typically have distributions, and the distribution of a variable tells us what values it takes, and how often it takes these values. And I said these data are the data that I collected last year from students. These are frequency. This shows this. We call it histogram. We will learn this later, maybe next class. Histogram. Okay, this is O. Histogram shows that which hour, 5 to 6, how many people? 4. Okay, 6 to 7, 2. Okay, like that. And then this is about sleep hours on average. And I can also use this kind of box plot. We are gonna learn this next time. And this is violin plot. Yeah, we need some beautiful visualization. If you want to attract people's attention, you need beautiful plots like this. So our lab has made a lot of beautiful visualization tools. Okay, so violin plot and box plot. Okay, so this is last night. The mean is 7, around 7. I think it is median. Median is 7. What the median is, you will learn next time. And on average, maybe 8 hours is a median here. So we learned what is statistics, and 5H, 5W and 1H. Why there is no one more W? There was Y. Okay. Data layout, data table. We learned columns are variables and rows are observations, and we learned about different types of variables: categorical, quantitative, identifier, ordinal variables. Okay, that's it. We are gonna have a Q&A session in the class. Feel free to bring questions. Okay, see you in the class.